Now, ang next nating pag-aaralan is SJF or shortest job first. So this will be the second CPU scheduling algorithm na ini-implement ni CPU. Okay, so ano bang nature ni SJF? Anong ginagawa niya? So basically, kung naalala niyo pa yung first come first serve natin last time, so ang ginagamit niyang criteria is arrival time. Now, with SJF, yung ginagamit niyang criteria in choosing pag nagkasabay-sabay yung process is yung burst time. Okay? Now, yung burst time natin dito is titingnan niya sino yung pinakamaliit yung burst time. So, ibig sabihin, pag mas maliit yung burst time, mas mabilis yung completion process ng isang task or job na binibigay natin with the CPU. Okay? Now, just like din ang first come first serve natin last time, non-preemptive priority din yung SJF. So, ibig sabihin, again, ng non-preemptive priority, once a process enters the CPU, so, kamukha din dito, pag yung process natin is nasa Gantt chart na, so, automatically, kailangan niyang ubusin lahat ng burst time niya. Okay? So, that is non-preemptive in nature. Okay, now, so, we'll be using the same example. So, kung naalala nyo yung mga given natin last time, so, ito rin yung given natin na ibibigay para makita natin ano ba yung differences ng implementation ng mga CPU or ng mga algorithm na ito. Okay? So, start tayo. Ganun pa rin. So, we'll be having our Gantt chart. So, drawing tayo ng Gantt chart. And then, tandaan natin, ang Gantt chart natin lagi nagsisimula at time 0. Ay, ganun pa din. Okay, so start na tayo ng computation. Now, kung maiisip natin dito, sabi natin criteria is burst time. Okay? So, kung titingnan natin, yung pinakamaliit na burst time dito ay si P1 and P3. But technically, either of the two, hindi sila yung mauuna. Okay? So, sino yung mauunang process natin? That will be P4. Okay? Now, bakit P4? So, dito common nalilito. So, take note nyo ito. Okay, so gagamitin mo lang yung criteria mo na burst time once na nagkasabay-sabay yung process sa RAM mo. Okay? So, ibig sabihin, for example, marami kang waiting dito. Doon mo gagamitin yung burst time. Pero technically, ang tinitingnan mo pa rin na una sa umpisa ay kung nag-arrive na ba yung process, kung dumating na yung process. Okay? Kasi try mong isipin dito. Darating yung P1 mo and P3, time 3 and time 8 pa. So, ibig sabihin, at time 0, hindi pa sila dumadating. Kaya, hindi mo muna papansinin yung burst time nila. So, ang titingnan mo ngayon, or gagamitan mo ng burst time, once na dumating na yung process, so, ibig sabihin, nandito na sila at nagkasabay-sabay. Okay? So, start tayo dito. So, si P4 at time 0, siya lang yung laman. So, technically, ipaprocess na natin si P4. So, kung makikita natin, ang ginagamit na burst time ni P4 ay 7. So, this will end at time 7. Now, at time 7, ganun pa din. So, titingnan mo, sino yung sino yung mga dumating at time 7. So, in between, from 0 to 7, sino yung mga nag-arrive. So, you have here P1, and then, you have here P2. Okay, so you have P1 and P2. So, technically, ayan, dahil nagsabay na sila, pareho silang nasa RAM, so, titingnan mo ngayon, sino yung pinakamaliit yung burst time. Okay? So, yung P1 mo was 4, P2 mo was 9, so, automatically, ang pipiliin natin ay si P1. Kasi siya yung pinakamaliit yung burst time. Ubusin mo yung burst time niya, mag-e-end yan at time 11. So, now, slash out ko lang yung mga tapos na. So, tapos na to. Tapos na din ito. Okay? So, yung P2 mo, active pa din kasi hindi pa naman siya napaprocess. Now, from time 7 to time 11, ayan, dumating yung P3. Okay, so ayan. Kamukha ng sinabi ko kanina, once na nagkasabay, gagamitin mo yung criteria. So, with this, ang active natin na process ay P2 at P3. Ang burst time ni P2 is 9, P3 is 4. So, technically, ang pipiliin ng CPU natin will be P3. Kasi ito yung pinakamabilis matapos. Okay? So, this will end at time 15. Ayan. So, at time 15, tapos na rin yung P3. Okay? So, still, yung P2 natin active pa din kasi hindi pa siya napaprocess. And within the time na pinrocess natin yung P3, dumating yung P5 at time 12. Now, so dito, dalawa again yung active na process. Pipiliin mo yung mas mababang burst time. One has 6 and then one has 9. So, mas mababa si P5. So, si P5 yung ipaprocess natin. So, this will end at time 21. Okay? So, at time 21, tapos na si P5, and then slash out natin, natitira si P2, tsaka natin ipaprocess ngayon si P2. So, this will end at time 30. Okay. So, ito yung kailangan nyo tandaan. Now, kung meron kang isang given lang dun sa mga problem natin, so for example, we have 8 algorithm, and then, isa lang yung given natin, always, kung ano yung end time na makuha mo sa isa, ganun lahat na makuha mong end time. Doon mo malalaman na tama yung ginagawa mo. And also, isa lang yung CPU utilization na makukuha mo. Kung nag 100% yung utilization ng isa, 100% din dapat lahat. Now, pag magkaiba yung answer mo, so ibig sabihin, meron kang mali. Okay? Meron kang maling na compute. Okay, now, so let's try to compute for the CPU utilization. So, kung tama nga. So, yun yung sinasabi natin kanina. Kung pareho ba yung makukuha natin. Okay, so we have here the summation of burst time. So, compute natin tong lahat. And then, we'll be getting 30. Okay, kuhanin uli natin yung last na total end time. So, we have here 30 again. So, times 100, so that will be 100% utilization. So, just like yung first come, first serve algorithm. So, next one, let's try to compute for the end time and turnaround time as well as the waiting time. So, ganun pa din. So, check natin anong oras nagtapos. Si P1, time 11. P2, time 30. And then we have 15, we have 7, and then we have here 21. So, same formula yung gagamitin natin. End time minus arrival. So, this will be 8. And then, this will be 25. We have here 7. And then, we have here 7 again. And then, so this will be 9. Okay. So, turnaround minus burst time for the waiting time. So, this will be 4. We have 16. We have 3. We have 0. And then, lastly, we have here 3. And then, so, we'll be computing for the average turnaround time and average waiting time. Okay? So, for the average turnaround time, so, computin lang natin to lahat. I-sum up lang natin to lahat. So, divided by, so 5 ulit, kasi 5 processes. So, let's try to compute this. So, for the average turnaround time, so we get 56. Okay, so this will be over 5, kasi 5 yung process. So, we'll be having 11.20. Okay, so for the average waiting time, so ganun din, sum up natin to. So, we'll be having, so this will be 26. So, divided by 5. So, this will be 5.20. Okay? So, now, i-compare natin yung nakuha natin for the first come, first serve. And then, nakuha natin for SJF. Titingnan natin, sino yung merong may pinakamababang average turnaround time and average waiting time. So, doon natin malalaman alin yung mas pinaka-efficient na algorithm between the two. Mas mababa, ibig sabihin, mas mabilis mag-react or mas mabilis tapos ni CPU yung isang process. Okay? So we'll be having another example. So this will be our second example. So ito rin yung binigay natin last time na merong mga idle time. So dapat, para malaman mo kung tama yung sagot mo dun sa una, dapat magkapareho sila ng makukuha na total end time. Okay? And then dapat yung CPU utilization nila is pareho din. Okay? So with this, kamukha ng sinabi ko kanina, kahit na burst time yung criteria natin, ang tinitingnan natin dito ay yung kung nag-arrive na muna. Okay? Kailangan mo muna malaman dumating na ba yung process. Now, at time 0, wala na namang dumating. So, just like nung kanina, nung first come, first serve. So, pinakamaagang darating is time 3. So, automatically, from 0 to 3, that will be your idle time. So, time 3, so you have here, P4. Okay? So, we have process 4. Si process 4 ay merong 3 na burst time. This will end at time 6. So, at time 6, wala pong process na darating na kasunod kasi pinaka-earliest pa is time 8. So, ibig sabihin, idle time ulit. Start tayo ng time 8. So, at time 8, so ito na. Okay? So, meron tayong isang process, si P2, yung process natin. Dahil siya lang again, yung laman ng RAM, siya lang ulit yung kukuhanin ni CPU. So, we have P2. Okay. So, this will end at time 12. So, again, para hindi tayo malito, slash out na natin yung mga tapos na. Okay, so yan. At time 12, ayan. So, dumating yung P1 mo, banda dito. And then, sakto, nung natapos yung P2 natin, dumating na rin yung P3. Okay, so, ayan si P1. And then, eto na si P3. Ayan. So, dahil dalawa yung active process sa RAM, doon mo gagamitin ngayon yung criteria mo na burst time. So, sino sa kanila yung may pinakamaliit na burst time? So, currently, pinakamaliit dito ay si P3. So, yan. So, siya yung ipaprocess natin. So, makikita nyo yung implementation ng algorithm. Kahit kakarating pa lang ni P3 nung time 12, na una naman ito dumating, dahil mas maliit yung burst time nito, automatically, siya yung pinili natin because of the criteria na ini-implement. Okay? So, this will end at time 16. Okay. So, at time 16, tapos na yung P3. So, ayan. And then, nandito pa din yung P1 mo. Also, dumating yung P5 dito. So, ayan. Dumating yung P5 at time 15. Now, so, nung dumating si P5 at time 15, so, meron tayong dalawang active process sa RAM. So, ito ngayon yung question. Okay. Pareho silang 5 yung burst time nila. Okay. So, tie sila. So, anong tiebreaker natin? So, ang pinaka-tiebreaker natin ngayon is arrival time. So, sino sa kanila yung nag-arrive ng mas maaga? Dahil pareho sila ng burst time, equal sila, kailangan natin i-break yung tie. Ang tiebreaker natin is arrival time. So, for example, kunyari, pareho pa rin yung arrival time nila. Same burst time, same arrival time. Ang pang-break mo naman dyan is yung process ID. So, ibig sabihin, ganito tandaan nyo. Kung ang criteria natin is burst time, ang mga tiebreaker mo is yung papuntang left side. So, ibig sabihin, ito yung magiging tiebreaker na una. Pag nag-tie pa din, so lastly, itong process ID. Okay? So, yan. So, balik tayo dito sa given. Parehong 5 yung burst time nila. Mas maaga nag-arrive si P1. So, si P1, yung ipaprocess natin. Okay? So, this will end at time 21. Same goes. Lastly, yung natitira. So, you have P5. So, P5 natin will end at time 26. Okay? Supposed to be dapat yung given natin sa first come, first serve, time 26 din yun nag-stop. Okay? Or nag-end. So, let's compute for the CPU utilization. Dapat same yung makukuha natin. So, isum up natin lahat ng burst time over dito times 100. Yan, so we'll be having 21. So yan yung total nito over dito sa last natin na value ng Gantt chart. So we have 26. So times 100. So you will be having 80.77. Alright, so this will be our CPU utilization. So 80.77%. Just like the first come, first serve algorithm. So, kamukha ng sinabi ko sa inyo, if we have the same given, so we'll be having the same end time, total end time, and then the same CPU utilization. Okay, now, so after this one, so computing pa din natin, so we have the end time, we have the turnaround time, and then we have the waiting time. So, P1 ends at time 21. So, P2 time 12, P3 16, P4 we have 6, and then lastly we have 26. Okay. So, end time minus arrival to get the turnaround time. So, this will be 11. And then we have 4. We have here 4 again. We have 3. And then we have here 11. Okay. So, turnaround minus burst time. So, to get the waiting time, so we'll be having 6. So, this will be 0. We have again 0. And then 0 again. And then we have here 6. Okay. So, let's try to compute for the average turnaround time and also average waiting time ng process. Okay. So, again, sum up over 5 kasi we have here 5 processes. So, let's try to compute. Yan. So, we have 33 over 5. So, this will be 6.60. Okay? And for the average waiting time, so we have here 12 over 5. So, we'll be having 2.40. Okay? So, that will be our shortest job first algorithm. Okay? So, try to compare again. So, sino yung nakakuha ng mas mababang average turnaround time and average waiting time, yun yung mas efficient na algorithm na i-implement for this certain given. Okay?
RR or round robin. So, ano bang meron kay round robin? Kay round robin, ang main difference nito is meron siyang quantum. Okay? So, ano bang ginagawa ni quantum? So, ginagawa ni quantum, definitely, kung makikita natin in our given, you have 3. Okay? So, every time na pumapasok yung process sa CPU natin, basically, bibigyan mo lang siya ng maximum 3 quantum na pwede siyang magstay dun sa CPU. So, after that, lalabas siya, papalitan siya ng ibang process para magkaroon ng equal opportunity yung mga process na makapasok sa CPU at a time. Okay, so ang advantage nito, so yung mga process natin is nagkakaroon ng chance na pumasok dun sa CPU, hindi siya masyadong matagal mag-iintay with the RAM. Okay, kahit paano, bits by bits, napaprocess natin yung mga jobs na binibigay natin kay our CPU. Okay, now, so dito sa part na to, so compute na natin sila. So, para mas madali, we'll be having a guide. Okay, dito sa taas. Ayan. So, yung guide, ito yung magiging basis natin, sino yung kasunod na process. Okay, so, and then this will be our Gantt chart. Yung implementation ni round robin, ang tinitingnan niya is arrival time din. So, ganun din. And then, depende na lang dun sa series ng guide kung sino yung susunod. Kaya kailangan tama yung guide natin. Okay. At time 0, so you have here P4. Lagay muna natin siya sa guide. Dahil siya lang naman yung nandyan, automatically, kukuhanin na ito ng CPU. Okay. si P4. Sabi natin, sinet natin na yung quantum natin is equivalent to 3. Kahit 7 yung burst time niya, kailangan niya mag-stop at time 3. Okay? So this will be 4. Now, next one, kailangan mo i-check, meron bang darating na process? So meron. Ayun, si P1. Si P1, ilagay na natin dito sa guide natin. Now, dahil si P4 hindi pa siya tapos, kailangan mo siyang ilagay dito sa dulo ni P1. Okay? Cancel out na natin to kasi na-process natin dito. Now, wala pa namang ibang darating kasi time 5 pa. Pwede na natin i-process si P1. Okay? Kasi siya yun nandun sa guide. Now, paano again pumasok si P1? Dumating siya time 3, ginawa natin, nilagay natin siya sa guide, and then si P4 hindi pa tapos, nilagay natin siya sa dulo ng bagong dumating na process. Okay? Kaya si P1 ngayon, so siya yung ipaprocess ni CPU. Now, yung sequence ng nasa guide natin, siya yung sequence ng ipapasok natin dito sa CPU natin. Okay. So, yung P1 natin, meron siyang 4 na burst time. So, isa na lang to. Next one, may dumating ba? Meron. Ayan, dumating si P2. Now, si P2, ipasok na natin siya dito. And then, yung P1 natin na hindi pa ubos yung burst time, ilalagay natin siya sa dulo. Ay, so you have your P1. Cancel out na natin to kasi pumasok na naman siya dito. Natapos to at time 6. Now, next one, sabi dito, uy, si P4 daw uli. Ayan. So, si P4, meron siyang 4 pa. So, this will be 1. Okay, sorry. So, this will be 1. Now, 1 na lang yung natira sa kanya. And then, nag-process tayo ng 3. So, this will be time 9. Next one, again, meron na namang dumating. Ito, si P3. So, sulat natin to. And then, yung P4 natin, lagay natin sa dulo kasi meron pa siyang 1. So, cancel out natin dito. Ito si P4. Next one. So, next na darating natin is time 12 pa. So, pwede tayong dumiretso. So, you have your P2. Ayan. Si P2 natin, 9 yung kanyang burst time. So, this will be 6. And then, mag-end to na time 12. Next one, dumating na ngayon si P5. Lagay natin sa guide. And then, yung P2, lagay natin sa dulo. Cancel out natin ulit. Next, you have your P1. So, ayan. Kung makikita mo dito, yung P1 na burst time natin is 1 na lang. Ay, definitely, dahil 1 na lang yan, 1 na lang yung maximum stay niya within the CPU. So, this will be 30. Okay. Now, the good thing dito sa given natin, dumating na lahat nung time 12. So, nung dumating lahat ng time 12, dito ka na lang dedepende sa guide natin, paulit-ulit na lang kasi wala na namang papasok na bagong process. Every time na mapaprocess, kung may material, lagay mo sa dulo. Okay, but in this time, yung P1 natin, so 0 na yan kasi naubos na yung burst time niya. So, cancel out na lang, hindi mo na siya susulat sa dulo kasi ubos na yung burst time niya. Next, sa guide, you have P3. So, P3 natin, may 4 na burst time, so mag-end to time 16. Next one, i-minus natin to. So, this will be 1 na lang. Next, so yung P3 natin is, meron pang natitirang isa. So, lagay natin siya dito sa dulo. You have your P3. Next, sabi, si P4 daw. P4 natin, isa na lang. So, times 17. Ayan. Cancel out na kasi 0 na yan. Next, you have P5. And then, P5 natin, 6 pa. So, 3 na lang. Lagay natin sa dulo, si P5. Okay. So, this will be times 20. Next, you have P2. So, 6 pa yun. So, process natin si P2 hanggang time 23. Okay, so this will be 3. Next one, so this will be, may matitira pa for P2. Lagay natin ulit sa dulo. Next, you have your P3. P3 natin, isa na lang. So this will be 24. Cancel out na to. Next, you have P5. Ayan, base dito. So si P5 is 3, so this will end at time 27. This will be 0 na. Cancel out na kasi wala nang natitira. And then last one, so ayan, you have your P2, and then this will end at time 30. So this will be 0. Okay, so ganun pa din. So kung makikita natin, yung utilization natin, sa pareho pa din yan. So sum nito, so you have 30 over 30 na total end time. So times 100, so you have here 100% utilization. Okay. Now, alam ba yung pinakasagot dito? Ang pinakasagot natin dito, ito lang. Okay? So yung guide natin, so wala yan. Okay? Hindi natin siya sinasama. Pero, importante yan kasi yun yung magsasabi sino yung susunod na process. Okay? Next one, so we have, again, end time, turnaround, and waiting time. Okay, so you have P2, you have 30, P5 is 27, P3 24, P4 17, P1 ayun 13. Okay, so end time minus arrival, so you have your 10, you have 25, you have 16, 17, and then we have here 15. Turnaround minus burst time, so this will be 6, and then you have 16, you have here 12, you have 10, and then you have here a 9. Okay? So, average turnaround time and average waiting time. Okay, so let's try to compute. Okay, so we have here 83 over 5. So we have 16.60. Okay, so for the average waiting time, okay, so we have here 53 over 5. So this will be 10.60. Okay, so this will be for round robin.
Okay, another example for round robin dito na meron pa rin tayong idle time. Okay, so same given. So check natin kung paano yung implementation. Okay, so lagay ulit tayo ng guide. So, liliitan ko lang yung sulat ko para magkasya. Given quantum natin is 2. Medyo maliit. Ibig sabihin, mas marami yung occurrence. Okay. So, this will be time 0. So, again, earliest arrival time natin is 3. So, i-idle na agad natin to. I no need to quantum yung idle time. Okay lang yan. Kasi, wala namang pumapasok na process. So, this will be 3. Okay, so, pinakamaagang darating dito, P4. So, ayan. So, given quantum natin is 2. So, nandito si P4. So, mag-end to at time 5. Now, at time 5, wala namang darating kasi time 8 pa yung next. So, si P4 natin, may matitirang 1. Okay? Bakit again? Given quantum kasi natin is 2. Dahil si P4 is wala namang darating na bago. Yung P4 natin, ilalagay natin sa likod ulit ni P4 kasi may matitira pa siyang 1 quantum. Pasok ulit natin si P4 dito kasi wala pa namang iba. So, this will be 6. So, next one, 0 na to, slash out ko na to. Now, this will be idle time again. Yung time 8. Okay, pero at time 8, slash out ko na rin to. we have here P2. So, ayan, meron na tayong P2 ngayon. So, dahil siya lang, yun nandito. So, you have your P2 ngayon. And then, 2 quantums. So, this will be 2. Okay? This will end at time 10. May dumating ba? Meron. Ayun, si P1. Okay? Si P1 natin, papapasukin muna natin. Okay, so ayan. So again, dahil may natira pa kay P2, si P2 punta sa dulo. Slash out ko na to kasi pumasok na yun dito. Next, sabi sa chart, so si P1 yung kasunod. Okay, so you have here 2 quantums, so this will be 3. Okay, so mag-end to ng time 12. Now, meron bang dumating ng time 12? Ayun, meron uli. Si P3. So, papasok muna si P3 bago natin ilipat si P1 sa dulo. Slash out na to. Okay. Next one, papasok na ngayon si P2 kasi siya yung nandun na next. So, lagyan na natin siya. And then, this will end at time 14. At time 14, wala namang ibang papasok kasi time 15 pa. Si P2, ubos na yung burst time. So, this will be 0. Slash out na natin to. And then, tapos na si P2. Now, no need to move kasi ubos na. And then, sabi sa chart, yung kasunod natin is P3. So, lagyan natin dito si P3. Okay? Current quantum burst time niya is 4. So, matatapos to time 16. Okay. Now, next one, dito, this will be 2 na lang. Okay, so after that, may darating na bagong process. Ayan, si P5. Ilalagay muna natin dito si P5. Again, yung P3 na hindi pa ubos, lagay mo sa dulo. So, you have your P3. So, slash out na natin to. Now, dumating na lahat. So, palit-palit na lang sila dito sa CPU. Okay, so you have your P1. And then, 3 quantums pa siya, mag-end to ng time 18. So, this will be 1. Hindi pa tapos, lagyan natin sa dulo. And then, cancel out. Next one, so you have P5. P5 natin is 5. So, this will be 3. Okay. Ayan. And then, times 20. So, dahil hindi pa ubos to, lagay natin sa dulo. We have P5. Next one, so you have P3. 2 quantums. So, this will be time 22. And then, this will be 0. Cancel out. No need to move kasi 0 na. Next one, you have P1. So, ayan si P1. And then, dahil 1 na lang yan, this will end at time 23. So, cancel out. And then, you have here P5. Lagay ulit natin. You have 3 pa. So, in this case, may matitira pang 1. So, stop tayo ng time 25. And then, lagay ulit natin si P5 dito kasi hindi pa ubos. Lastly, si P5 ulit yung papasok kasi siya na lang. And then, this will end at time 26. So, same goes. Computein natin yung CPU utilization. In this case, sum ng burst time again. So, you have 21 over 26. Ayun. So, times 100. You have here 80 point. So, you have 80.77. Ayan. Okay, so next one. So, end time, turn around, and then you have waiting. So, compute natin sila. Okay, so for our end time, so P5, that will be 26. And then, you have 23 for P1. P3, you have 22. P2, ayan, so you have here 14. And then, P4, you have here 6. Okay, so end time minus arrival. So this will be 13. You have your 6, 10, 3, and then you have 11. Okay, so turnaround minus burst time. So this will be 8. Again, sa original natin mina-minus So this will be 2. You have 6. You have 0. And then you have here 6. Alright, so let's try to compute for the average turnaround and average waiting time. Alright, so sum again. Yan. So we have 13 plus 6 plus 10. So this will be 43 over 5. So this will be 8.60. Alright, so next one for the waiting time. You have here 22. Alright, 22 over 5. So this will be 4.4. Okay, so this will be our round robin.